Retrieval Augmented Generation, or RAG for short, is the most commonly used solution to generate answers using LLM from the data it is not trained on. We retrieve relevant chunks of data from unseen data and then give it as context to LLM to generate answers to queries about that unseen data. Over the years, RAG has evolved and people have started using different kinds of data to create rich RAG applications. In this video, I will explain how you can build a RAG app that uses YouTube video transcripts to answer questions about that video. We will use open source LLM Llama-3 served through Groq API to build our RAG app. The coding will be done using famous LLM apps building framework LangChain. So without further ado, let's get started with the coding part. Alright, so I have kept the total code for this tutorial in this Jupyter notebook. I will include link to it in the description so you can download and follow along. At the beginning of the notebook, I have highlighted the important sections of this tutorial. So first of all, we will load LLM. So we will load a wrapper around LLM through which we can call it. Then we will load the YouTube video transcripts. So LangChain provides a wrapper class which we can use to download the transcript of a particular YouTube video or list of YouTube videos. Then we will generate embeddings. For this one, we will use Llama tool. So Llama let us access open source LLMs on our local machine. So for generating embeddings, we will use local LLM. Then we will split documents. So the transcript that we loaded for the video needs to be split into a list of strings. So we can't give the total transcript in context. We will split it into documents and then we will give only relevant documents to the LLM. And then we will build index in the vector store. So for this, we will use the Chroma vector store. And for the documents which we split, for those documents, we will build index using the embeddings. And then at last, we will create a RAG QA engine, which will be based on these vector stores and the loaded transcripts. So you need to install these two libraries in order to download the transcripts of a YouTube video. And that transcript will be used to answer questions from that video. So please feel free to install these two libraries. So first of all, I have load environment variables. So I have kept the Groq API key, which we will use to access our LLM Llama-3 in our current directory where I have kept the .env file, and I have loaded that environment variable file through this .env. And over here in this variable Groq API key, the API key is available. So in the first section, we will load LLM, and for that we will use Groq as I said. And if you don't have account on Groq, then I would suggest that you log into Groq through this URL console.groq.com, and there is a section to create API over there. So feel free to create API from there. Then you can follow along. And next I have highlighted the models which are available through Groq. So these are the models: Llama-3, 70 billion and 8 billion version, Gamma 7 billion, 9 billion version, Mixtral. And there are two other models which are fine-tuned for tool use. So these are the models freely available. Now because they are freely available, there is a limit. So there is a 30 requests per minute limit for each of these models. So in order to use Groq API or LLMs to Groq API, we need to import chat Groq from LangChain_Groq. So you will need to install this wrapper as well, this Python library LangChain_Groq as well, in order to access this. So then we can create an instance of chat Groq by giving API key, which is our Groq API key. And the model we will use Llama-3 70 billion. And temperature I have set to 0 because I want a deterministic model. If the temperature is greater than 0, then the model tries to be creative and generate different answers each time. So that's our model. So once the LLM is loaded, we can call it by invoking this method .invoke on it, and there we can give whatever query we want to give. And the response will be the AI message. So as you can see, this is the response. We ask it how's life, and it say I'm just AI. I don't have a personal experiences or emotions. So that's how you can load and call LLM. Next, let's go ahead and load the transcripts of a YouTube video. So for that, we need to import this class, so YouTube loader, which is available through LangChain community.document loaders. And for our purpose, I have included the link to the YouTube video. So this is the LLM intro video from Andre Karpathy. And Andre Karpathy is a famous computer scientist which has worked on earlier versions of GPT, ChatGPT. So he has created a video, 1 or 2 hour long video giving introduction on LLM. And we will use the transcript of that video for our RAG application. So for creating or for loading the transcript of that particular video, we can call from YouTube URL method on YouTube loader class. And over there, we need to provide link of the YouTube video. And then we can also provide add video info to true. So if you want to include some metadata about the video, then you can set this parameter to true. So that will create a loader object. And then we call the load method on it. And that will return a list of documents. Now in this case, it's one video. So it will return a single document. And that document, as you can see, docs of 0, has a total transcript of that video. So the transcript of the video is present in this document object. The total transcript of this 1 or 2 hour video is present. And we can also access the metadata. So that's what I have done over here. You can call dot metadata attribute, and there the information like what is the title of that particular YouTube video, how many view counts, thumbnail, publish date, what is the length of the video in seconds, and who is the author, so channel name. These are available through metadata. So yeah, so we loaded the transcripts and it was loaded as one document. Now you might want to load transcripts in chunks. So let's say that you want to load transcripts at 30 seconds chunk. So you can do that as well using the same from YouTube URL method. But this time you need to provide a parameter named transcript format. And over there you need to import this transcript format from documentloaders.youtube. And that transcript format has 3 attributes: chunks, lines, and text. So if you want documents in chunks, then you can set this parameter to transcript format dot chunks. And then you need to provide the chunk size in seconds. And that you can set to like 15 seconds, 30 seconds, 60 seconds, however you feel comfortable. And once you do that, and if you load the documents, then as you can see, this time it loaded 120 documents. So the previous example where there was only one document and it had the total transcript of the video. Now that is divided into 120 documents, and each document has 30 seconds of data. So 30 seconds of transcript is present in each of the documents. Now this transcript format has other parameters as well. So other attribute is lines. So if you want to include per line documents, so this count will go even higher, above 120, because the transcript format is lines and the document is created per line. And then there is a text. So text one is the same as our previous one, as if we have not provided. So that way it will load only one document and the total transcript of the video will be present in that single document. So you can also check the metadata in this case as well. So majority of the things are same, but there are 2 other attributes. So start second, as you can see, for the first one is 0, and from 0 to 30 second data will be present. And then in the second one, the start second is 30. Start time step is 30 seconds. So that was the second one will start from the 30 seconds because we have set chunk size to 30 seconds. And yeah, you can also check the page content. So this is the page content or the content of that particular document. Next, let me explain you how to generate the embeddings for a string. So for that we will use Llama. So Llama is a tool, for those of you that don't know, Llama is a tool that lets us run open source LLMs on our local machine. So in order to generate embeddings through Llama, any LLM available through Llama, you need to import Llama embeddings from LangChain community.embeddings. And over there you can provide the model name. So in our case, I am using Llama-3 again to generate embeddings. But this one by default will access 8 billion model, and that will create an embedding LLM. And to generate embedding of any string, we can simply call this method embed query on LLM, and there we can provide a string. So for query, how are you? If you want to generate embeddings, then you can call embed query function, and that will return embedding, which I have printed over here. And the list of and the length of the embedding is 4096. So that's how you can generate embedding for single string. Now if your list of document, which is our case, so we have list of strings, and if you want to generate embedding for list of strings, then you need to call this method embed documents on the LLM object, and that will return embeddings for each of the documents. So as you can see, this time embeddings has a length 5 because there are 5 strings or 5 documents, and each one has length 4096. So that's how you can use Llama to generate embeddings. Next, we need to split our document into list of documents. So we cannot give the total transcript of the video as a context to our RAG application. We need to retrieve only relevant documents. So we need to retrieve only relevant chunks of data from the total transcript and give those as a context to LLM. So there is a less tokens used, less amount of tokens are used. So in order to split the documents, we can use a recursive character text splitter class, which is available from LangChain text splitter. And this will generally split content based on 2 new line characters. So you can create an instance of text splitter, and then you can call split documents method on that object. And over there we can give docs. So in our case, docs is just one document object, which has a total transcript of the video. If you are using more than one videos, then that will have more than one documents, which will be split further. And the result this time is a document, but the original transcript is divided into 17 documents. So now that we have divided our original transcripts into list of documents, list of chunks, 17 chunks to be exact, let's go ahead and create an index in our vector store. Now for this tutorial, I have decided to use a Chroma vector store. So it's freely an open source vector store. So you can load it from LangChain community.vector store, and you can import Chroma class. And in order to create a vector index, you simply need to call from documents method on this Chroma. And over there, you need to provide 2 arguments. First is the list of documents, which is this 17 documents which we created. And the second one is the embedding LLM, which LLM you want to use to generate embedding for these documents. Now in this case, I have also passed this argument process directory. So this one is optional. If you don't pass, then it will create a vector index in memory. And every time you want to use RAG application, you will have to rerun this cell. And this cell takes time to rerun. So that's why I have used a process directory. That way it will create a vector store in the folder video underscore RAG underscore DB, and this folder is present in the current directory. So next time if you want to load this index, then you simply create an instance of Chroma, and over there you can give process directory from where you want to load load this vector store. So once you have created an vector index from Chroma, you can create a retriever by simply calling this method as retriever on it. And now we can use this retriever to retrieve relevant documents for any input string. So that's what I have done over here. I have called the invoke method on that retriever. And over there we need to provide dictionary where input is the key and the value is the string or query for which we want to retrieve the relevant documents. So I have a simple query that what are author's view on LLM security? And I want to retrieve the relevant chunks from the original transcript that were relevant to this question. So we can properly answer this question and we can understand what author thinks about the LLM security. And by default, the 4 relevant documents are written, but you can change this and retrieve less or more documents. And then you can loop through relevant documents and print their contents as well. And that's what I have done. As you can see from the first document, poisoning or backdoor attack, and another way to maybe see it this like a sleeper agent attack. So from this you can understand that the author is talking about some kind of attacks on LLM, and so he is talking about LLM security. So we can be sure that yeah, the retrieved document is actually talking about the LLM security. Alright, so now that we have completed the individual parts of building our QA engine, like we created vector index, we loaded LLM, we loaded embeddings LLM, and so on. So let's go ahead and create the complete QA engine, RAG QA engine. So for that you need to perform few imports. So from langchain.chains.combine documents, you need to import this create stop documents chain method, and we will use it to create a chain which will combine the relevant documents. Then there is a chat prompt template, which will be used to define the template of our input prompt. And then there is a method named create retrieval chain, and this function will be used to create our actual RAG QA engine retrieval chain. So first of all, I have created a prompt, which you can do by calling the from template method on chat prompt template class. And over there, I have provided the string which defines our prompt. And the prompt is simple, that answer the following question based on the provided context and your internal knowledge. Give priority to context, and if you are not sure, then say that you are not aware of the topic. And then we provide context. So context will be the text of the relevant documents. And then there's a question, which is the input query. So first of all, I have called this function create stuff documents chain. And there I have given the LLM, our Llama-3, which we loaded earlier, and the prompt. Now what this function does is that it creates a chain, and that chain accepts as input the actual query and the list of relevant documents. And it will take list of relevant documents and retrieve their contents and combine all of them into one string. And that string will go over here into the context. So document chain, simply as the name suggests, stuff documents, it combines the input documents and put them into this prompt and give it as input to Llama-3. And then we are creating the retrieval chain using the create retrieval chain function. And the first argument is the actual retriever, and the second one is this document chain. So the flow will go like this, that when user sends input query, that input query will first go to retriever. And from retriever, the list of relevant documents will be retrieved. Those relevant documents along with the query will go to document chain. And then document chain will combine the contents of those documents and create a one string, and we'll give it over here. And the query will go over here. And then the total prompt, the one with the documents and query, will be given to Llama-3 to generate answer. So that's the flow of our retrieval chain. So let's go ahead and ask a few questions to our RAG QA engine to see how it's performing. So in order to call the RAG chain or retrieval chain, our QA engine, we need to call the invoke method on it. And there we can provide the dictionary. So dictionary has a key input, and then there is a query. So what are author's views on LLM security? And the response is a dictionary, as you can see, and the dictionary has a 3 keys: input, so that's our input question; context is a list of documents, which are the relevant documents that were retrieved from retriever; and answer is the final answer generated by our LLM. And I have printed the final answer over here, and as you can see that it's saying that based on the provided context, the author's view on LLM security are concerned. The author is concerned about the various attacks on the LLM security and aware of cat and mouse game. So author acknowledges that there is an ongoing cat and mouse game between attackers and defenders in the field of LLM security, and emphasizes the need for ongoing research. So this is the response generated based on the context, and this is the context. So you can also retrieve context. So this is the document, and this one is talking about various attacks. So it's about the security. So 4 documents are retrieved. So let's go ahead and ask a few more queries. So next I have asked that summarize the author's views on attacks on LLMs. And from the response, you can see it's talking about the various attacks, that poisoning or backdoor attacks, then sleeper agent attack, shield break attack, so on. So different kinds of attacks which author has described in his video are over here, and our LLM generated is based on the transcripts or chunks of transcripts that was provided to it. Next, I have asked that how does author describe LLM? So based on the provided context, it has generated a few bullet points describing how author describes LLM. Next, I have asked that what author tries to explain through James Bond example. So if you see the video, the author tries to explain the concept of sleeper agent or backdoor attack in LLMs through James Bond example. So specifically, the author is explaining how an attacker could potentially embed a trigger phrase like a James Bond into training data, which could cause the model to behave in an undesirable way when it encounters the phrase in a prompt. So that's how he describes that he uses James Bond as an example phrase to explain the sleeper agent or a backdoor attack. Next, I have asked that what are authors' views on limitations of LLM. So on based on for limitation, it's mostly describing various attacks and lack of robustness. So over here, he's again talking about attacks can be demonstrated to work for fine tuning. It's not clear if they can be convincingly shown to work for pre-training, and need for ongoing research and development. Yeah, so those are a few limitations which author highlights. And then again, I have asked another question, which is the last one. And so what are the stages of LLM training according to author? And as you can see from the answer, it has retrieved two stages, pre-training and fine-tuning. And fine-tuning is generally also referred to as instruct tuning. So the two stages of LLM are properly retrieved from the transcript of the video. Alright, so that's how you can create a RAG QA engine over YouTube video, over the transcripts of YouTube video. Now for this tutorial, I use only single video, but if you want, you can use a list of videos. You can answer or query some podcasts, some videos on podcasts, some codes. So you can try various things with different videos. You can include list of videos. So yeah, that's it. If you have any doubts or any questions, then please feel free to let me know in the comment section, and see you next time.